So, let's talk about GitHub. How many of you use GitHub on a daily basis? Yeah, me too. So GitHub is home to the code of roughly 31 million developers and 2.1 million organizations. So we're talking about a scale of about 100 million repositories on GitHub. So when they go down, it's a pretty big deal. And on October 22nd this year, around 2 a.m. in the night on the US East Coast, everyone started seeing the cute 500 page with the unicorn. To their credit, despite it being late at night, GitHub responded pretty immediately and got the pages responding again, so you could look at your data on their website. Even though they couldn't guarantee metadata consistency. What this basically meant was that you had a fancy Git remote to which you could push your code and pull code from it. But the site was unusable for anything except that. So pull requests, issues, comments, anything like that didn't work at all because you you didn't have consistent data. Fortunately, GitHub has a status page, and they used that to communicate throughout the incident. It was read for most of 24 hours, and they posted a blog post with a post-incident analysis after, and they said that they were down for over 24 hours. That's not great. The thing here, though, is that how they handled the incident is pretty much the state of the art. I think they did a really good job despite being down for so long. They communicated transparently throughout the incident. They made some estimates that turned out to be wrong, but that happens. We are developers. And these incidents happen all the time. So it's very close to impossible to actually avoid having these kinds of incidents. For example, Slack was down in most of Europe just this September for several hours, and they called it connectivity issues, but it basically meant that no one could send messages, which is not great. But they also have a very, very, very good routine for handling incidents like this. But what I'm getting at is that when something like this does happen, you do not want to be this guy. And that's me, by the way. I'm Martin, and in that picture, I'm on call at FINN.no, which is Norway's largest online classified ads site. Yeah. I was hanging out with friends at a restaurant, and customer support in this picture has just informed me by phone that publishing classified ads doesn't work. And publishing classified ads is kind of our thing at our classified ads site. So I told them to hold on, took my phone down, looked at it, and had 0 notifications, which is not great. So all I could do was reply, really? I'll have to check that out. And then that's why I have this resigned expression, and I'm sure they looked pretty much the same when I had no idea that anything was going on. So this talk is named Good Service, and I'm here to tell you about what we've learned from countless moments of nearly blind debugging at FINN. I'm going to give you an overview of how we approach monitoring of a system of microservices, which tools we use, and how we respond to incidents. So this talk is almost exclusively about how we do things at FINN. I have recently switched jobs, but I was still able to give this talk. I now work at a company called Folio, which is a startup, where I've gotten to reevaluate many of the decisions we made at FINN. And most of them hold up. I mean, it's great, but I have some new perspectives as well. So let's start off with a bold statement. Nothing is worse for your service's reputation than being unwittingly down. By which I mean, if you're down and you don't know it, so your customers have to inform you that you're down, then that's terrible for your service, because people talk. So that's the main problem I'm going to tackle over the next 40 or so minutes. You can put all the work you want into advertising and social media campaigns and sales, but if your service doesn't work, then you're not going to be able to make any money. You should see FINN's Facebook page when something is wrong and we haven't told them about it. Even if we tell them about it, users are still going to complain on Facebook. But you know, and it just takes a few minutes of reduced service before people start complaining. So if this is someone's first impression of your service, they're not going to come back. FINN is lucky enough to have a monopoly in Norway on classified ads, which in this context just means that users choose to put up with some of our crap. But most companies are not in that position, and when you're trying to claim a market somewhere, you need to get this right. You cannot be down like this, because then you'll just be associated as that service that's down. So people won't use it. They go to your competitors. Instead, you want to look something like this. This is what FINN looks like when the load balancer isn't serving up error pages. From this page, you can basically just what FINN is. You can search for classified ads, browse ads by category, create new ads, send messages to advertisers, sellers. And we somehow got people to come to our site to look at ads. And then we put ads around the ads so we could make money off of the traffic. And that's our business model. It's great. And apparently there was some kind of chocolate milk powder crisis thing going on in Sweden, and people were selling chocolate milk powder for millions, and I don't even know what happened. But those are my recommended ads at the time I took this picture. Yep. So just a quick overview of the case. FINN has about 6 million unique users per week. It's a site that's strictly in Norwegian, and there are 5 million people in Norway, so please don't ask me about that. There are roughly 150 developers, and they build and maintain somewhere between 350 400 microservices. We mostly use Java and Node.js, but teams are free to choose their stack. They just mostly choose Java or Node.js, but there is at least one Haskell app in production, which is a thing that happened somehow. So there is a dedicated operations team at FINN, but their job is to build the infrastructure, and we have mostly designed our infrastructure as code, which is great. So people working in the ops department are developers, and they develop the platform we run the apps on. They do not manage the actual user-facing apps. But despite that, we managed to isolate almost all incidents to in just a few seconds after we get a notice that something is wrong, and we limit most reduced service to just a few minutes. So we have had some large-scale outages as well, as every company does at some point, but those are almost always caused by network misconfiguration or an uplink that goes down in the network or load balancing being configured wrong, like things like that. Global components that you can't really do anything about as an app developer. So one important thing to note here is that when a service actually does have issues, it's the developers of that service's responsibility to fix it. To get a feeling for the traffic patterns we deal with, which is a big thing when you're trying to monitor your service, here's a graph of one typical week for FINN. It shows the number of hits per second to one of FINN's biggest web servers. And the numbers here don't actually matter, but the peaks are around 600 requests per second for this service, and the lows are about 50 requests per second, so 650. FINN is a Norwegian service, so it's kind of to be expected that the traffic patterns follow the Norwegians' habits. You can definitely tell when people are asleep. You can tell when people are home from work. And from playing around with this graph, you can also tell some interesting things, like the Norwegian lunch break is between 11 and 1 at almost every company, which is that little spike. Traffic peaks after the kids are put to bed and the news have been watched every day. And Saturdays have lower traffic than the rest of the week, every single week. Probably because people spend time with their families and friends on Saturdays. But not Sundays, though. That's our weekly peak for some reason. There are some things you cannot tell by this graph, though, and I'll get back to that in a bit. But let's get down to the core of this talk. Let's start by painting the ideal picture so we know what data we need to collect to actually be aware of when things are going wrong. And I'm going to say you need to prioritize when you try to figure out how to monitor your service, you need to prioritize answering questions like how users typically flow through the system. And the thing you care the most about is if those flows are being interrupted for some reason by anything right now. And if something is wrong, you need to figure out which flows are being interrupted, which parts of the flows are being interrupted. And that will help you determine things like which user segments are affected and how many individuals are affected. Because we've had cases of a single ad for a single person generating thousands and thousands of log messages per second, which made it look like everything was completely down, but it just turned out that his user hadn't been synced to a system that needed to have that user. So it just spammed and spammed and spammed, which was not great. And it took like half an hour to figure out that it was only one user and not everyone on the service. So just to show you, here's one of our first attempts at building a dashboard. We used Grafana for that. I'll get back to that. The dashboard tells us how many new ads were created in the last 15 minutes, how many ads of those created ads were actually published in the last 15 minutes, how many payments are completed per second, how many payments, well, that's a good indicator of how many people actually complete their flows, and so on. So most of the time, this is more than enough to catch an error very early, because if the ad service goes down, then it's impossible to create and publish ads. So you'll see these graphs just dip, go down to 0. And just getting this dashboard with Grafana improved our error discovery times and resolution times for incidents a lot. Like suddenly, we didn't have to rely on customer service to tell us that things were down anymore, which was great. And again, note that this dashboard is made using Grafana. So besides exposing these metrics and storing them somewhere, we haven't written any code yet. So all you need to do is take numbers you already know and expose them somewhere that you can query them with, like Grafana or some other dashboard visualization tool. So one of our first lesson learned here is that choosing good metrics is really hard. It's almost impossible to get it right on the first attempt, but you have to start somewhere. And when you are going to start somewhere, you need to keep in mind that your users only care about one thing, and that's being able to use your service. So your focus throughout this process of implementing monitoring for your services should be how and if an error affects your users. Different teams at FINN approached monitoring from several different angles, and the most successful one by far was the dashboard I just showed you, where you start out with defining a few business metrics, like how many ads were created in the last 15 minutes, how many of them were published, how many payments are going through the system. And then you can work your way towards balancing them later. That works so much better than trying to start with like log error messages per 15 minutes. And once you're there, you can start answering questions like, should you prioritize fixing this error at midnight, or can it wait for tomorrow when someone with actual knowledge of the service is available for fixing it? Will it fix itself? That happens sometimes. I mean, it shouldn't, but we've all been there, probably. And will patching the error now cause more damage in some way? You can probably tell that once you have your business metrics. Or if it happens, you can at least understand that it happened, that it's happening. So let's talk about one of the cases I worked on a lot, which is ad insertion. I worked there for over 2 years on that particular thing. And in this slightly simplified model, we have a browser. It talks to a public backend. That backend does some authentication and some convenience stuff, and then it reads and writes classified ad data to an ad service. Eventually, the user makes a payment to publish their ad, and that triggers some work that pushes the ad into the search indexes, and suddenly your ad is online. It's available. People can search it. People can get notifications about it. So that's our stack. So there are some different metrics that you can look at for this case, such as the time taken from when the ad was created until the ad was published, whether the users started and published the ad in the same session, like did they sit down with their computer, create the ad, fill it out, and publish it in one go, in one setting. Did the users start and publish the ad on the same type of device? So one thing we learned at FINN is that many people prefer creating their ads on a mobile phone, take pictures with their phone of the thing they're going to sell, and then they go to FINN on the web, on desktop, to actually fill out the rest of the fields and publish the ad. That's one thing we learned from doing this. How many finished ads have been published in the past 15 minutes from the dashboard? How many payments have been authorized in the past 15 minutes, also from the dashboard? And how many hits per second do we have to our services versus the same time 7 days ago? So on the left here, I think we have some good metrics for giving us insight into how users interact with your service. It's good for determining, for learning about user behavior. But I think the ones on the right are good metrics for actually monitoring your service level. And it's really hard to get this, to separate this. Like, it's no black and white. It's always going to be grayscale, whether one metric is more useful than another. But I think it's good to focus on how the users are actually interacting with your service and how many of their attempted actions actually succeed. However, so remember the traffic graph from earlier? This is 1 week. One of the good things about this graph is that the consistency of it lets us compare data from now with data from 7 days ago. And doing that usually catches errors anywhere in the stack quickly, and you don't have to account for things like nights, because if people don't use your app at night, then people didn't use your app at night a week ago either. So the traffic is going to be pretty much the same. So if all you care about is like deltas and deviations between now and 7 days ago, you'll be able to figure out, quickly figure out if something is wrong right now, which is good. But there are some things you can't see in this graph, though, because we're only measuring traffic. So one interesting thing is that the highest traffic rate on the job listings at FINN is Monday morning, just after the lunch break. So people go into work Monday, work through the morning, go to lunch, chat with their colleagues, go back to their computer, and then look at jobs. Yep. And also, there are some things you can't really avoid. Like Christmas Eve and New Year's Eve are both extremely noisy for the on-call. Like, you get notifications about no one using your service, and I'm like, yeah, I know, it's Christmas dinner time. Yep. So as another example, this is the number of searches per second at FINN's most popular marketplace, which is just bits and pieces, like everything. If you have a couch or a toaster or something you want to sell, you put it out there. And obviously something is wrong here, right? We've dropped from 550 requests per second, searches per second, to 400 something. And it sure does look that way. And when you compare this data with data from 1 week ago, you're gonna get hits. Like, it's gonna tell you that something is wrong. But no, it was this guy running for gold at the European Championships. Yep. It's estimated that 1.1 million people out of 5 million people in Norway watched that race. So that 1 hour, like the actual race and then the coverage after, was watched by so many people that we thought we were down. And this has happened with series finales and other sports events so many times, in addition to like public holidays and times when people spend time with their family. So there are two lessons here. The first one is that no metric always makes sense, because sometimes there's a media event or a sports event or something going on that distracts your users from using your service, or sometimes it's just been Easter, people have gone out to their summer house for the first time this year, found a lot of stuff they don't really care about anymore, brought it home, and put it out on FINN. So we have like a huge increase in traffic just after the Easter weekend. And the second lesson here is that no metric makes sense by itself. So when you, one more time. So when you see a rate change in traffic, or when you see a change in the number of published ads in the last 15 minutes, you have to balance your metrics somehow to be aware of, is this a problem, or is it just because something else is happening? So we have to always compensate for one metric with another metric that tells you if something is actually wrong. And it's no way, I've tried, and you can't predict every major entertainment event or series finale or how people are going to react to those. So we have to compensate. We have to put in some other types of metrics to tell us if the error is actually an error or if it's just a deviation. So I like to divide metrics into two categories. Business metrics for user behavior, and system metrics for application monitoring, like memory, CPU usage, number of 500 responses versus 200 responses to web requests, HTTP requests. So for business metrics, I like things like number of hits per time, per minute, per 15 minutes is usually good for our level of traffic. Number of new ads in that same time, number of completed payments in that same time. I think those are really good metrics for ad insertion. Like, these are the things you care about. If these deviate, then you'll know that something is wrong. But you should also compensate with some system metrics, like how often your services are being restarted. Is something causing your apps to crash? That's happened before. How much latency is there in the network, and how long do your apps take to process each request? If it suddenly takes like 5 seconds to store an update to an ad, then people aren't going to be able to use your service. And number of log messages per level, like how many error log messages do we have, is a really good metric when you also suspect that something is wrong because of another metric. So when something actually is wrong, you'll very often see a deviation between now and 7 days ago. So you're suspicious that something is going on. And then you'll almost always also see a spike in number of error log messages per second, which is good. So you have balanced your metrics. And also things like if you have queues in your system that you feed data into and have some processor like publish things to a Kafka cluster or some messaging bus, then the length of those queues are also very good indicators that something is actually wrong. And if that happens, then you almost always know that it's because something is wrong with your applications. So we made a dashboard, and we put both business metrics and system metrics in it. And obviously this thing could have been done with Grafana too, but Grafana didn't have the same capabilities back then when we started doing this, which is like 4 years ago. So we ended up building our own stuff. But one lesson learned is how much of a difference it makes when you have a dashboard. So I would say there are two sides to getting started. You need to gather your metrics, and then you need to display those metrics in a useful way. Because if you don't display them in a useful way, then people aren't going to be aware that there is a problem, even though you have all the data you want to generate metrics or to build metrics. So by far the most important thing here is to have a dashboard that displays your business metrics. I don't think the dashboard you start out with has to be completely real time or interactive or written by you or full of colors or fancy at all, really. Just make sure you know how your users flow through your system and whether that flow actually works or whether the users are being disrupted. So now that we know something about the data we want and what type of data we want, which tools do we use to collect it? So at FINN, we roll our own stack. our applications run in a Kubernetes cluster, but everything else is like we have a service provider, but we've installed things ourselves. And we use quite a few different tools for measuring, but Prometheus is easily the most important tool in our stack for the sake of this presentation, because we collect all our business metrics using Prometheus. And Prometheus has client libraries for all major application programming languages like JavaScript, Java, Go, and so on, Python. And it's pretty simple to get started with it because there's no like reporting sequence or anything. You just expose your metrics on a URL and you'll get a request every 10 seconds or so where you're just supposed to display your metrics, and the Prometheus server does the rest. So we have a common Prometheus service also installed into our Kubernetes cluster that automatically scrapes every single app for metrics every 10 seconds and stores those metrics, that data, into its database. We also have some other tools. We use Kibana to search our logs. Zipkin is great for request tracing if everyone uses it. If not everyone uses it, then it's kind of useless, which is one of the big downsides of tracing. But yeah. And for front-end error reporting, I'm not going to get much into that, but we use Track.js, and even though it's not free or open source, it is really good, so at least consider it. We also obviously have application logs. So we have FluentD. It listens for application logs, stuffs on standard out. It stuffs those logs into Elasticsearch, and then we use Kibana to query the logs in Elasticsearch. So this catches a lot of issues that don't directly impact user flows because we pay attention to things like how many error log messages we have per second. And when you know there's a problem, then having this stack is just invaluable. It's easily the most useful tool for locating the actual error when you know that something is wrong. And I bet most everyone here is familiar with this stack or something like it. So one thing I think we got right at FINN was making it really easy for the developers to set up measurements. For example, apps don't have to do anything fancy with their logging. They have to log JSON in a standard format that we provide a client library for all the major languages at FINN. And they just have to write that JSON formatted log, those JSON formatted log statements to standard out, and FluentD does the rest. Like, you don't have to do anything in your application to configure logs. And we also turned on, this is kind of a weird, kind of a big decision, but we turned on Prometheus metric scraping by default. So it's expected that if you deploy an application to the FINN Kubernetes cluster, then you do expose Kubernetes metrics, Prometheus metrics. And that's kind of a big thing when you're doing this for a microservice fleet or whatever you want to call it. That's 350 services where none of them had Prometheus metrics at all 2 years ago. We started out with some stats.d graphite thing, but then migrated to Prometheus after. So the goal here is that to have all teams implement active monitoring of their services so that every single team is aware when something is wrong. And that's not going to happen unless you start out by establishing some ground rules, like which technologies can we use for collecting collecting data, and how do we expose that data as metrics. And you also, in my experience, you have to provide some kind of shared infrastructure with sane defaults. So we chose Prometheus, installed it globally, and every single application's metrics are reported to that and stored in that single Prometheus instance, and that works well for us. We also chose Grafana as a single visualization tool and dashboard, and that Grafana instance has access to all the data in the Prometheus server, so every single team can use that. And another big thing here is that if you're setting up something like this and you have 200 developers, then every single team is not going to care at all because it's worked before, right? So you have to help the teams get started, make them aware of why they should monitor. This is a big thing, apparently. And help them set up, like, let them know their responsibilities and help them set up the monitoring for at least one or two of their services so they know how to do it, and you build some kind of competency in the team. So it's a big thing to help the teams get started, or we wouldn't have gotten anywhere with this. So when we have our data in Prometheus and we have our logs and we have all we need, basically, we need to start monitoring them. And how can you monitor your data in a useful way? So you've already seen this dashboard. It's still heavily used at FINN, even though we have our own custom dashboards now. And we use Grafana for all visualizations of the Prometheus data, like except things that can be condensed into a single value, like number of log errors per 15 minutes or number of ads published per 15 minutes. If you need to see a graph, then, or any type of chart, then Grafana is the way to go at FINN. Which means, like, Grafana is free, it's open source. You can just install it and deploy it. So you don't actually need a custom dashboard to do these things. Grafana wasn't this good when we started, though, which is why we have our own custom stuff. So this is where we get into the homegrown stuff that's been really good for FINN and worked really well for us. Here are two of our main dashboard types. So obviously we have enough teams that people started building their own dashboards in parallel, and then we ended up with like 2 or 3 different types of dashboards. But they have pretty much everything in common. Like any given dashboard can be in one of 3 states. Green, which means keep doing what you're doing as a developer. Yellow, which is someone has to look into something because some threshold has been exceeded. Like maybe we have 2 slightly fewer ads being published per 15 minutes than we did last week, or maybe we have a slight increase in number of log error messages. And then finally, the dashboard can be red, which means all hands on deck. Like you need to get someone to look at this right now, because then that means that something is seriously wrong. And the worst status of any metric determines the main status of the entire dashboard. So if any single metric, any single line is red, then the entire dashboard is red as well. And also, one thing I think we got right with our custom dashboards is that every single metric needs to also be a link to either relevant logs or documentation to tell you what that metric means. So every single metric is a link. You can click it and get to some relevant information. That gives us a lot of dashboards, though. So what we did was to provide a high-level overview. We implemented a meta dashboard thing that pays attention to our core business services and just condenses them into a single box. So one of those is ad insertion. Another is search. Payments, airline tickets, every single core business service has its own box here. And the way that works is that this dashboard queries the other dashboards so that for a set, like a predefined set of metrics, and if any of those are red, then the core business services dashboard box also gets red, and then alerts start being fired by text messages and emails and Slack channels, and all hell breaks loose. And when that happens, the team has to act immediately. Like if this dashboard is red, then you have to be on top of it. And we also display this dashboard by the customer service people so that they will be immediately aware that something is wrong or that something is going on if this gets red. To actually alert when something is red, we use Sensu. So the way we set this up is that Sensu queries both all the team dashboards for if you're interested in everything, and also it queries the core business services dashboard. And if the core business services dashboard says that something is wrong, then Sensu starts firing alerts to the on-call and to anyone else who should be responsible for this or for the incident. So you can, in your dashboard, you can tag every single metric, and the way we've done it is we've given every core business, every really important thing that you need to look into during the evening, we've tagged with core business services. And then we've configured Sensu to query, query for core business services. And generate alerts. We've also done things like team names, and this dashboard on the left here comprises both payments and ad insertion, because it's technically one team, but it's two different domains. So we've also separated that so that the right person gets the right messages. Yeah. One thing is that Grafana has come a long way since we started, though. So you can define a threshold for all chart types now, and have Grafana fire alerts if the value exceeds that that threshold. So, and Grafana now can alert through, in my opinion, all of the important channels like Slack, pushover, email, or just you can just configure it to fire a custom request like a webhook, so that if a threshold is exceeded, you can have it post its payload to any URL of your choosing, which is great. But we spend a lot of time implementing these dashboards. And while building a dashboard is a lot of fun, and it's an excuse to try out whatever new front-end tech is cool this week, we only built dashboards ourselves because the existing off-the-shelf free solutions weren't good enough. I have a new job now, though, and we're running everything on Google Cloud, which means that we get Google's like stack driver thing that does everything I've just shown you for us. And we get that integration pretty much for free, so if we can not have a full team develop dashboards for several weeks, then we're golden. Like, we're 8 developers, so we don't want to waste resources on that. So I would say that a really important thing is that you should look at your provider's available options before you embark on building your own dashboards, and only build them if you actually need it, even if building a dashboard is a lot of fun. So that leaves us with one final question. How do we respond once we actually receive an alert? So to actually respond to incidents, we've taken a leaf out of the book of emergency first responders to crisis areas. And we have a well-defined, if simple, incident management framework that helps us not waste any time on process when something is actually wrong. IMAS stands for Incident Management at Schibsted, which is the company that owns FINN. And then we implemented our own version of that. So we have IMASAF, which is Incident Management at Schibsted at FINN, which is a great name or something. So when something actually is wrong, we have a checklist to follow. We have our reports to, well, we have our documents to write. We have our ways to communicate to leaders that something is going on. We have our ways to notify customer service. But I mean, at this point, if something is so down that you need to actually declare an incident and initiate and invoke this framework, then we welcome all hands on deck. Like, make a Slack channel, and if you want to help, then just join the Slack channel. Try helping out. That's how I got started and got pulled into this. And a process framework doesn't exactly tell you how to identify an error. Like, it's no point in trying to implement that into the framework. This just tells us which roles we have in our plan. Like, so you have a communication lead, you have an operational lead actually doing the investigation and things like that. But you also need to be able to figure out what's wrong. And as on-call, I had responsibility for debugging every single core domain at FINN if something went wrong during the evening. But that doesn't mean that I have any idea how the airline tickets or direct messaging services work, or that I have ever used them personally. So that's where our hierarchy of dashboards is very useful, because if the core business services dashboard is red and I get an alert, I can open the core business services dashboard, see that the search box is red, and then get taken directly to the search dashboard, in which I'll see immediately that only one of the boxes is red, so I know kind of what's going on. And hopefully I can click that box to get some relevant documentation. If not, then at least I know who to call, right? someone with responsibility for search. And that is an immense help in pinpointing the issue. So this kind of drill down thing, even though it's not like drilled down in a single dashboard, is very useful. When something is so wrong that we've declared an incident, we're in all hands on deck mode. We have our spammy Slack channel where people are trying to figure out what's wrong. We too let our users know. But we've taken a slightly different approach from GitHub and Slack though, because we've implemented a kind of broadcast banner thing that can be green or yellow or red. And that lets you know, you can choose like which types of pages you want to put this on. So if it's an incident that only affects, if the incident only affects ad insertion, then you can choose to only display the banner on ad insertion pages. And then every single web app has to support this broadcast thing. So that's kind of more of a process decision than it is a, well, it is a technical implementation, but this has to be decided high up for people to actually implement it. And this banner does a whole lot to like calm the storm of phone calls that come to customer service when something is actually wrong. And finally, after the incident is resolved, we file a report, as you do. And one thing I've learned from doing this is that determining downtime is really hard. Like determining exactly what is wrong and who it was wrong for and how long it was wrong for is really, really difficult. So in the report, we have a table that you fill out where you kind of cross out if the incident affected apps users or web users and how many of those users were affected. And I've written 14 incident reports, and not a single time has it been easy or straightforward to fill out these boxes. And this is where you really need your business metrics from earlier, because you need to figure out what was wrong, who it was wrong for, and which flows were being disrupted. So we're back to flows and understanding your application. So I think determining what to do, how to respond, how to inform the right people, how to inform your users, and how to summarize the incident and figure out how to make it not happen again is really important to have determined in advance. So one of our biggest lessons learned after like countless hours of blind debugging that didn't even result in a report is that you need to implement an incident response plan ahead of time. So you don't want to be wasting time on logistics when things are on fire, and I don't just mean like defining a process framework. I also mean determine how the on-call goes about finding out which services are affected and how the on-call can reach the correct people. And finally, we've gotten to the boring summary slide that's designed to be taken pictures of and not looked at, but I'm going to do it anyway. So I think you should make sure that you know if your users can use your system normally, like are the flows being interrupted. Do make sure that you have an actual dashboard that displays this information in some way that makes sure people are aware of it. Also implement alerting, obviously, if you can. Make it as easy as possible to do measuring for the teams. Make sure every single team is actively monitoring their services. And decide on a shared infrastructure for storing and querying data and displaying data, because otherwise people won't care in the organization. I think you should not start out by cluttering the dashboard with system metrics. And by that I mean don't put hundreds of system metrics like log messages per second into a dashboard and call it a day. Even though you have a lot of metrics, it doesn't really tell you anything about how the service operates. You don't know what kind of service level you're at. So I think you should start with a few business metrics and then balance them out once it turns out that they aren't enough. Don't make your teams figure out anything on their own, and don't have your teams run their own reporting and metric stacks. That doesn't work. You'll just end up with like several different implementations that differ way too much to actually be able to maintain them. And then when the one person who's done most of it quits, then the team is just stops doing monitoring, which doesn't work. So do this globally. And also don't waste time on process when things do go down, because things do go down, and things sometimes go down for an extended period of time. We can't really avoid that, but make sure you have defined a plan. Make sure you know what to do. Make sure everyone knows what to do. If you think these problems sound interesting and want to chat, drop me a line on Twitter or send me an email or something. I have been Martin, and this has been Good Service. Thank you.